Thank you. A little bit under the weather, so I apologise in advance for my nasal voice and if I sound a little bit lower energy than usual. And thank you to the CrikeyCon program committee for accepting my talk yet again. For some reason, I keep proposing and they keep accepting, so I think that's great. It's great to be here again. And as mentioned, I'm talking about something a bit different from the PKI and applied crypto things that I work in my day job and that I've presented on in the last few years. I'll be presenting about a user session recording tool or suite of tools that is being developed by some of my colleagues at Red Hat. I don't work on it directly myself. I've read the internals, I'm aware of what's going on, so I do feel qualified to present it today, but just in the interests of full disclosure, not something I actually work on myself. So first, why do we want to record user sessions in the first place? I imagine for many of us, the idea of having our sessions recorded, even in our day job, is unappealing. And there can be good reasons why it's undesirable to do so, or undesirable to be recorded, even if what you're doing is your legitimate work. But there are some good reasons why you might need to do it as well. So, in some cases, there are government or industry regulations or kind of internal self-regulations that dictate that on particular systems or in particular environments, user sessions need to be recorded. Some organisations want to track what contractors are doing when contractors are in their organisation, doing things on their systems or to their systems. And for incident recovery, some organisations want to record sessions so that they can analyse, okay, who broke the thing, how did they break it, and this can help in diagnosing how things went wrong and potentially in recovery as well, but certainly for prevention for future issues. Some companies and some governments really do want to record everything users do on all of their systems, but that's typically not the case. Most organisations, certainly if you're large enough to have risk analysts and so on, they'll be quite aware that this is not something that they want to do organisation-wide. They want to apply it discriminately according to the value and the use of a particular system, the kind of work that system does and the kind of activities that people do on it is going to dictate whether or not you want to record sessions. So companies want to record sessions sometimes, and when they do, they want to store that recorded data somewhere safe. They want to get it off the system and get it across a network securely to some system where it's stored securely, and then they're going to want systems for retrieving that information, searching through it, so they can find out who did that thing, how did they break it, what's happened here. There are a number of commercial offerings in this space, and they range from application-level proxies on dedicated hardware to user space processors on systems of interest. They range from recording keystrokes to recording displays, so actually recording the graphical output of a system, recording which commands have been executed, which applications are running, URLs that people are visiting, and so on. So there's a whole, when you talk about session recording, there's actually a whole bunch of different things you could be talking about recording. No solution that I'm aware of does everything. Some of them do multiple things, and some of them just focus on one particular area. Typically, you would want them to be integrated with your organisation's identity management systems and access control systems so that you can, in an automated fashion without requiring a lot of administrator effort, apply your policies about who needs to be recorded or which systems need to be recorded under what circumstances. So you don't really want administrators to have to implement these policies and deploy them individually to every system in the organisation. That's simply not practical. So you want to integrate it with your identity management somehow. And of course, there are requirements around how the data are stored and searching and playback capabilities. So plenty of commercial offerings out there that do some subset of what I've just talked about. Customers are often not satisfied with these solutions because, first of all, they can be horrendously expensive, as security solutions often are. And being proprietary, they have no introspection into what the program is actually doing, whether it's doing its job properly. If it's not quite meeting their requirements, they are not able to get it. If it does 90% of what they need it to, they can't quite get it to that 100%. And if it's broken, they can't fix it themselves. They're beholden to an organisation. They go cap in hand and say, can you please fix it? And maybe they will, maybe they won't. So they can't improve it themselves, they can't help their neighbour. Red Hat, as hopefully many of you would be aware, all of our solutions are open source solutions. So it's something we believe very strongly in. So customers want lower costs, they want open source solutions so they can fix it or at least understand it better, be able to read what's going on, and of course commercial support. So when things aren't working as they should, they at least have some recourse with, for example, Red Hat or whoever. So don't we have this already? Don't we already have open source session recording tools? Yes and no. There's a program called Script that does terminal I/O recording using Script and a whole heap of DIY duct tape. You can cobble together a semblance of a session recording solution. This is popular and it's often used by students or people in kind of academic contexts for recording what they did on the system as a proof that they did something or in order to be able to review work that they've done. But it's not at all a security-oriented solution and it's not turnkey. There's lots of DIY, so it's not suitable for business environments or commercial environments. There's sudo I/O logging. Sudo is a security tool. The I/O logging capability is pretty good, but it's only going to be doing its job if you're actually using sudo to execute commands. So sudo is, in case you don't know, is a tool for escalating privileges according to a particular rule set that says who can execute which privileged commands. So if you use sudo to do everything, then sudo I/O logging is a fine solution. But if you don't use sudo to do everything, which is usually and hopefully the case, then this is not really a complete solution. There's also TTY audit with audit-D. So this is a tool that takes its data out of the audit subsystem in the Linux kernel. It's security oriented. It can be centralized, but there's no turnkey solution there, and it only records input. It doesn't record terminal output. I'll talk a bit more about the trade-offs there a little bit later. So in summary, no, we don't really have a complete solution. And I could also point out that none of these deal with the identity management integration requirements. So what do we need? There are 5 aspects. First, we need a program to record terminal input and output. We need prompt, secure, centralized logging. We also want to log kernel audit events. And we need a tool for searching and playback of recorded sessions and correlating the terminal activity with the audit events. So not only can you see what was the user actually doing in their session, but what effect is it having on the system? What programs are being executed, what system calls are being executed, what network activity is occurring, and so on. And finally, centralized control. So we're going to look at each one of these aspects in turn. So first, for recording terminal I/O. The first, I guess, complete solution to come out of this project at Red Hat is the tlog program, tlog for terminal logger. It's a shim between the terminal and the shell, started at logging for a user. It can log to files, to syslog or to the systemd journal. It uses a JSON message format, and it also comes with a tool for playback to the terminal. So, what's the next slide? Okay, yeah, I'll talk about this, and then I'll switch to a demo. So some of the features, beyond the obvious, it records terminal input and output. It also records window resizes. So if you're changing the size of your window, that data can be recorded and that can be reflected in a playback program. There's a configurable "you are being recorded" notice. It can be turned off or it can be on with a whatever customized notification you would like. That's there because it's a regulatory requirement in some industries, so like PCI DSS and so on. You can tune it for low latency versus low overhead, so you can either batch more data into a single message and send them less frequently, or with more overhead but lower latency, you can send a lot of smaller messages. So that's a tunable, and there's also rate limiting, so if you cat dev random to your terminal, you can configure a rate limit, so if it recognises it's being flooded, it can just shut down, which means that that particular session is going to stop being recorded, at least until the flood stops. It's a trade-off. I mean, if someone does that, you may not want to record everything, and if you do record it, you're putting yourself at risk of a denial of service, because either there's too much network traffic or your storage fills up. So yeah, there's no perfect solution here. You need to work out what's going to work best in your environment, and balance your risks versus your desire to record everything that's happening. Okay, so a quick demo. On this system here, on the left-hand pane, I'm going to SSH actually back into this same system, but that's incidental. So I'm going to shell in here as the sus admin. And what will I do here? Maybe I'll cat etc password and have a look what accounts are on this system. Maybe I'll do an ls of etc, see what configuration files are in there, and I might run top and see what's running on this system. And over here, let me just see. If I now run tlog play, I can replay this session out of the terminal. I'll just subtract, say, a few minutes from that. Okay, so we can see it's found a session and it's going to start playing back everything that was happening in the left-hand pane there, hopefully. If the demo gods are smiling upon me this day. Yep, so there we go. You can see there was a little bit of lag there, but everything I was doing in the left-hand pane is now being played back on the right-hand pane. I'll just log out on the left-hand pane. So how is this actually configured? If I have a look at etc password, grep sysadmin, you can see that the shell here, okay. So the shell is a program called tlog rec session. That's the main session recording tool. I'll talk a bit more about more dynamic ways to configure session recording for a user in a moment. Okay. So the minimal setup, the login program invokes tlog rec session. That can record to whatever sort of recording output format you want, the journal, syslog, or just a flat file, and then later tlog play can play that session back. How it works, the user authenticates to the login program via PAM. The NSS, so the name server switch, tells login tlog is this user's shell. Login starts tlog. Tlog looks in the environment and falls back to static configuration to work out what shell program to actually invoke for the user. It forks the sudo terminal and then logs everything that goes in between the slave and the master ends of the pseudo terminal, and everything it logs, it formats as these JSON messages and sends it to that output. The JSON format contains a number of fields. Rec is just a UID or a unique ID for that recording. Also contains a session ID, which is non-unique, but it will be unique on a given system at a given time. The user, so who was the user who logged in, ID, the ID field is a sequence number of messages in this recorded session. The timing field contains timing information about how much data to read from the actual data fields at what particular time intervals, and also contains metadata like session resize events. And then the in text and in bind and out text and out bind fields contain the binary and text input and output data that that travelled across the pseudo terminal. At the right is the journal message format. So as well as including the whole message, we lift some of these fields from that JSON message up into journal parameters. So we store tlog rec, tlog user, session ID, and the sequence number. And so you can see when I ran tlog play with reader journal, the -m field is used to give search parameters for the journal reader, and we say tlog user equals sysadmin. So this is actually reading these sort of dynamic or arbitrary key value data in the journal entry. So that's how it's finding the session. S is a start time, so it's a start searching the journal at this time. Okay, so moving on, logging infrastructure. So we need an open source scalable solution, preferably with an active community, for actually getting the logs off the machine and into some centralized storage. So yes, there are solutions for that already. We're using Elasticsearch and Kibana. These are being brought into the Red Hat portfolio as the VIQ project, which are going to normalize logs, put them into Elasticsearch, and provide the dashboard and analytics. The VIQ is seeking to have a unified approach to this kind of common logging or centralized logging across Red Hat's whole portfolio. So it's already got an OpenShift component or interface for doing this. They're working to bring it to OpenStack and to other parts of the Red Hat portfolio. And yeah, so for delivering to Elasticsearch, you can use any popular logging service. So VIQ is what we're working towards, but until then, you can use FluentD, rsyslog, Logstash, whatever you're comfortable with. So for logging audit events, so the audit subsystem provides the AuDispD, so that's audit dispatch daemon, which is a component of Linux that reads messages from, there's a special network device in the Linux kernel that sends these audit events, but it's a totally ad hoc binary format, and your tools need to know how to read it. So ORShape is taking these messages and then massaging them into a kind of nicer, I guess, and more digestible JSON or XML schema that we are actually defining. So it's going to sit between the audit subsystem and your centralized logging server, where you're actually going to need messages in a nicer format that's going to facilitate searching and correlation. So the kernel sends messages to auditd, auditd passes the messages to AuDispD, and then AuDispD distributes them to plugins. ORShape is one of these plugins. So it reads the message, formats the JSON according to the schema, and then logs it through syslog, and from there your standard log forwarder will send it off to Elasticsearch. So an example event, this is just an execve event. The left-hand side and the right-hand side are the same event, just one is XML, one is JSON. So this is the schema that the ORShape project is defining for transforming these audit subsystem events into a more standardized schema. Okay, so for playback and analysis, our initial proof of concept is using the Cockpit web UI for session searching and session playback, and then eventually we're going to have Kibana solutions and something for visualizing, not just playing back, but also the correlation with what's occurring in the audit log. We need some way to visualize or make this information digestible to a human who's actually wanting to perform these searches and analyses. We don't quite know what we're going to do for that yet. We haven't designed it. So if you have ideas about how that should look and what the user experience should be, we're really interested to hear your thoughts. In terms of the proof of concept, here is on the same system as a moment ago. This is the Cockpit interface for that system, so I'm just going to log into that. And from there we can go to the session recording tab. It looks like I already searched for a session, but here's a list of all the sessions. You can filter by username or date, or username and or date. And if we pick one of these, I'll just embiggen it a bit. No, that's okay. So I'll just play it, maybe speed it up a bit. So what was this person doing? The sysadmin telnetted to yarncat.daco.us and looked at yarncat for a few minutes. Yeah, and so we've got fast forward. You can speed things up, slow things down, go back to the start. I'll talk a bit more about that in a second. How am I doing for time? Just 5 minutes left. Okay, good. So how Cockpit UI works, basically at the moment, the browser sends requests to the Cockpit server. The Cockpit server reflects the user's search as a journal search, sends the events back to the browser, and the browser plays them in a JavaScript terminal emulator. For centralized control, that's the fifth and final aspect to what we need of a kind of holistic session recording solution. Naturally, we're going to be using FreeIPA and SSSD. So FreeIPA is an identity management system. It's a program I work on quite a lot, but mainly on certificate management features. SSSD is the client component. So you can sort of think of FreeIPA as like Active Directory, but for Linux and Unix systems. And SSSD is the kind of the domain client on a client system. The session recording controls, we've not implemented this yet. The SSSD side is implemented in terms of actually defining the rules that SSSD are going to read. We haven't done that yet, but we're pretty sure that we're going to augment host-based access control rules to include a flag about whether user sessions should be recorded if a user is admitted according to that host-based access control rule. So basically it'll be an extra boolean on an HBAC rule that says if they come in on this rule, either record them or don't. With SSSD, when SSSD finds a match for the user in its configuration, PAM SSS, that's the PAM plugin for SSSD, will store the actual user shell in the PAM environment and then lie to login and tell it that the shell is tlog. But the user environment will contain this information about what the user's shell actually is, so when tlog rec session runs, it will read that environment variable and know, oh, okay, I actually need to go and run Z-shell or bash or whatever. And as I mentioned with FreeIPA, we're very likely to implement this by linking the session recording configurations to HBAC rules. Okay, so wrapping up, this is the summary of our approach. So we're going to use tlog for recording sessions and ORShape for transforming audit subsystem events, and we're going to ship them off using rsyslog, logstash, VQ, whatever, into Elasticsearch, and then we're going to have tools, Kibana, Cockpit, or whatever else we come up with for digesting the information out of Elasticsearch. So performing searches and actually presenting playback and other information about what users did in this session and what was the effect of what they did. But those bits are, apart from the proof of concept in Cockpit, how we're going to do that bit is not yet determined. And as I mentioned, we'd love your feedback. For the control side, FreeIPA and SSSD are going to be used to configure T-log on a target system as to whether to record sessions or not. And then Ansible playbooks for setting all of this stuff up. Challenges, don't record passwords. How do we do that? Kind of a hard problem, or how do we not do that? Yeah, kind of a hard problem. At the moment, all we say is don't record input. So the default configuration is only record output on the terminal. Often that's enough, because you see the full effect of what the user did, other than when they're in a no echo mode or kind of a full screen console application. Seek, rewind, and resize. In playback, we currently the way we do seeks or rewinds is basically go back to the beginning, reset the terminal, and play everything back in. Eventually, we'll look at having keyframes to make that a bit more efficient. Correlation, as I mentioned, visualizing the correlation or presenting that information to users. We don't have a design for the user experience for that yet. And security. So, you know, there are probably going to be ways that you can circumvent this. The tool runs setuid, so there's certainly a lot of care needs to be taken to avoid privilege escalation vectors and so on. And finally, what T-log isn't. So I've talked a lot about what it is. In case it was not clear, I would like to point out that this is all user mode. There's no kernel mode component other than audit D, which is something that's already running. We just want to be able to use the information that is coming out of the audit subsystem a bit better. But T-log doesn't have any code running in the kernel. It's not a command whitelisting or blacklisting tool. There's no way to configure it to not run a user command if they type a particular command, or to let them only run particular commands. We don't do that. We're not trying to be that. We don't do graphical session recording. We're not trying to do that right now. There are other tools for that. Maybe we'll look at it in the future, but at the moment, what our customers are asking us for is something for console sessions, because most of our customers are running RHEL on servers. And it's not a one-stop security shop, of course. Hopefully I don't need to belabor this to you, but you know, this tool is going to be one source of intelligence. It can be useful for recovery. It can be useful for analysing what went wrong when something went wrong, or how someone did something bad. But it's not designed to prevent these sorts of problems. So it's one tool in your security toolbox, not a complete security solution. So all of these projects I've been talking about are, of course, free software. So you can find most of these tools in the Scribery project on GitHub, and VQ is its own organisation. If you have suggestions, if you want to try it out, if you find bugs, please come and contribute in any way you feel able. And if you want to contribute more, let us know how we can help you do that. And with that, I think there might be no time for questions. So I'll be around for the rest of the afternoon.